Okay, this is particle kinematics. No, not kinematics, particle kinetics number 26. Um, and it looks like this. There is a ramp here and a ramp at a slightly steeper angle on the other side. There's a pulley in between. And then there's carts on each of these two ramps. Um, this one has a mass of 10 kilograms. This one has a mass of 12 kilograms. And they're connected to each other by a cable. Okay. And then the left incline, it says, makes an angle of 20 degrees with the horizontal. And the right incline makes an angle of 30 degrees. And it asks for a few things. So I'm not going to go through all the different parts, but I'm going to go through the heart of this problem, which is calculating the acceleration of either one of these and calculating the tension in the cable. All right, so to do that, we're going to draw free body diagrams and use Newton's second law for each of these two carts, one at a time. We're going to come up with some equations, and we're going to see that to solve that system of equations, we're going to need to have a relationship between accelerations, which is just basically going to say that if the 10 kilogram accelerates up the ramp, the 12 kilogram accelerates down its ramp with the same magnitude. And then we'll just solve that system of equations. Okay, so first, Newton's second law for the 10 kilogram. There's the cart and the forces. There's a weight force of 10 times 9.81, so 98.1 newtons. There's a pushing force from the surface that I'll call N10. And then there's a cable force. I'll call that T. And the only one of these that we need to use cosine and sine for, okay, well, I didn't mention this, but this is important for rolling and sliding problems. We're going to use that coordinate system where the y-axis points straight out of the surface. And the x-axis has the relationship that, that we're used to, just rotating that coordinate system. So the x has to be that way. Okay, so now let me draw that coordinate system. And the weight force is like this, where this angle is 20 degrees. So as a force vector, that's going to be 98.1 times cosine and sine of 270 minus 20 is 250. All right, well, let me calculate those components. That comes out to be, the x component is negative 33.55, and the y component is negative 92.18. And now we're ready to go to Newton's second law. I wrote Newton's second law here. This is the free body diagram, not Newton's second law. Okay, so Newton's second law says we have this weight force vector we just calculated, negative 33.55, negative 92.18. 0.18. And then we have the tension force in our positive x direction. And then we have the normal force in our positive y direction. That's all the forces. And that's equal to the mass of this body times its acceleration. So we just have to know for this one that the acceleration, let's call it A10, is along the x-axis. We don't have to know the sign because the sign will work out on its own. Okay, well, we could calculate the normal force from this, but that's not gonna, nothing asks for that, I don't think. So instead, there's only one equation that's useful to us, and that's the one that says, I'll rearrange it, but it says 10 minus 10A10 is equal to 33.55. We can't solve it because that's a single equation with two variables, but I'll call that equation 1. We'll just put it aside, and then we'll use it to solve a system of equations. And now we're going to draw a free body diagram of the second body, the 12-kilogram cart. Okay. For this one, there's a weight force that's 12 times 9.81. So that's 117.72. And then there's a pushing force from the ground, the normal force, I'll call that N12. And then there's the cable pulling. And since it's the same cable as the other one, I'm going to call that T, like I called the other one. And for this one, our coordinate system is going to be, so we're going to use a different coordinate system for this one, with the y-axis pointing out of that surface and the x-axis along the surface. And again, the only tricky one, the only one where we have to use cosine and sine is for the weight. So here's our coordinate system. There's x, there's y. The weight force is that with a magnitude of 117.72. And we know that this angle is 30 degrees. And so the theta that we have to use with the cosine and sine would be negative 60 or positive 300. And so that weight force vector is going to be 117.72 times cosine of 300, 117.72 times sine of 300. Let me calculate those. So we get positive 58.86 and negative 101.95. And now we can go to Newton's second law for this one. We have the weight force we just figured out. So 58.86 negative 101.95. Then we have the weight force that's in the positive y direction. So did I say weight force? Normal force is in the positive y direction. So normal 12. The cable force is in the negative x direction. So that's negative T0. And all of this is equal to the mass of this body, which is 12, times the acceleration of this cart. Well, notice something here. If our first cart is accelerating in the positive x direction, its positive x direction, our second cart is actually also accelerating in its positive x direction. Do you see that? So based on these coordinate systems, if that 10 goes in the positive x direction, it's going up the ramp. The 12 is accelerating down the ramp in its positive x. And so these accelerations, A10 and A12, have the same value. We can put this in here as, I'll write this in as A10. And so now, again, the y equation doesn't really help us, but we have this equation that says negative t minus 12 A10 is equal to negative 58.86. We'll call this our equation 2. And now we can solve equations 1 and 2 as a system of equations. Let's see. I'll add these two together. That'll cancel the t's, but you can do this with substitution or whatever. So now I'm going to solve this system. If I add those two equations together, we get 0t minus 22a10 is equal to 33.55 minus 58.86, and that gives you negative 25.31. And now you can solve for A10. A10 is equal to positive 1.15. Okay, well, and then if you wanted the tension in the cable, you could plug that A10 back into either one of those two numbered equations, find T. This question doesn't ask you specifically for the magnitude of the acceleration, but it asks you for a bunch of vectors, and you can get all those by just plugging these values of T and A10 back into Newton's second law expressions to come up with vectors and stuff. So that's the basic idea of this problem. That is particle kinetics number 26.